Large language models are amazing but painfully slow to run. What if we could make them lightning fast without giving up on accuracy? That's exactly what VLLM does. Let's break it down clearly, simply, and step by step. Let's start simple. vLLM stands for Virtual Large Language Model. It is an open source project developed to make running LLMs faster, more efficient, and scalable. It is not a new model like ChatGPT or BERT. Rather, it is a backend system that powers how these models respond. The LLM uses a novel technique called paged attention, which changes how attention is computed during generation. With traditional LLMs, when users send long inputs, the system has to store and reprocess all various tokens every time it generates a new word, which is slow and memory hungry. VLLM solves that with smart memory management, reducing duplication and enabling batch processing across thousands of concurrent users. Here is a quick story. Imagine running a bakery, but you bake each loaf of bread one at a time from scratch. Now imagine doing that for 10,000 customers. That's what traditional interface looks like for LLMs. Each user's input is treated separately, requiring full memory allocation and recomputation. This causes high latency, slow replies, high memory use, poor scalability, and if you are an enterprise or AI startup trying to deploy models at scale, that is a major bottleneck. Now, here comes the game changer paced attention. It is like a smarter filing cabinet. Instead of pulling out every file every time, it keeps the frequently used pages ready and organized. Paced attention introduces a virtual memory mechanism, allowing the system to share key value memory between multiple sequences, avoid recomputing past tokens, dynamically manage memory allocation. This leads up to 24x times faster throughput and much better GPU utilization. Imagine now baking 10,000 loaves at once, but by using a massive conveyor belt. That's paged attention in action. One of the coolest features of vLLM is its ability to handle multi-user batch interface. In real-world applications like chatbots or coding assistants, there are many users sending messages at different lengths and different times. VLLM scheduler groups similar requests together and processes them in parallel using dynamic patching, memory aware allocation, GPU efficient scheduling. This means AI can serve more users in less time with lower cost and higher quality. Let's peek under the hood of vLLM. Its architecture includes Model Executor, which loads and runs the actual LLM, Paged Attention Engine, which is a memory manager, Request Scheduler, it groups and manages inputs, Token Manager, which will track generation and output. Each part is designed for performance. vLLM runs on top of frameworks like PyTorch and supports models like LLaMA, OPT, Falcon, and GPT-2. It integrates with Hugging Face easily, making it flexible for researchers and startups alike. You might be wondering, does this really work? The results are super impressive. The throughput up to 24x times more tokens per second than Hugging Face transformers. In latency, it drastically reduced response time. In GPU memory, more efficient storage and usage, which allowed larger batch sizes. In A/B tests, vLLM often serves 3x to 6x more requests than traditional LLM engines using the same hardware. In reality, where can you see vLLM in action? AI chatbots that respond immediately, code generation assistants like GitHub Copilot, enterprise virtual agents, real time translation tools. Any service that uses LLM and needs fast, scalable interface can benefit from vLLM. Let's visualize the difference. In traditional interface, redundant memory storage, slow generation, one user at a time. In VLLM interface, shared memory, faster output, multiple users in parallel. Think of it like moving from dial-up internet to 5G. How does vLLM compare to other optimization tools? In deep speed, it is great for training and model parallelism, but more complex to configure. In faster transformer, low-level C++ speed but lacks flexibility and support. In vLLM, it combines simplicity, flexibility, and efficiency. Its secret sauce is paged attention, which others don't have. So, who should care about vLLM? If you are an AI developer deploying LLMs, a researcher prototyping faster interface, a startup building real time AI features, a company trying to cut down cost on cloud, then vLLM is for you. It gives you speed, scale, and savings without the complexity. VLLM is actively evolving. Future improvements include support for multi turn conversations, streaming outputs, integration with model training, support for newer models like Mistral, Cloud, GPT, Neox. It's becoming a one stop shop for efficient language model deployment. To wrap it all up, VLLM is not a model but a performance engine that supercharges your LLM deployments. It makes AI faster, cheaper, and more scalable, and it is open source. If you learn something new, make sure you hit that big fat like button. It will motivate me to do more informative videos on AI. Thanks for watching and keep building smart.